There we go. Okay. I said Melissa wanted us to be going over some of these, and we were going to kind of just talk them out and describe what they are as if we were describing them to people who don't know how to code, right? So did you
Okay.
guys get through any of that?
Yeah, that sounds familiar. She would have us look at something incomplete. Because she was trying to do two things. One, describe what's happening,
Hmm.
and then try to figure out what it's missing.
Oh, try to figure out what it's missing. Oh, like any kind of other.
Yeah,
I
but
don't
I
understand
think
what that means.
like for example, you have a function, a for loop, and it was missing a return, but she was doing that purposely to try to force us to focus on simple things instead of trying to solve what the outcome would be.
I see. I see. Okay, cool. All right. Well, here, let's go over some of these really quick, and you and I can start. And some of these I don't know. So some of these I don't know if I would be able to describe them perfectly. So we'll see.
By the way, the I had clicked another link you have in chat, that
Hmm.
Melissa put. It's different than yours. Just letting you know because I was there for
Yeah,
at least 2 minutes.
I noticed that because I didn't see her link. I had to remote into her computer to sign in to give myself permission for this one. So
Gotcha.
I didn't want to go back out and redo that again and then like be, jumping between different Zooms because it's kind of a process for me to have one so that I can record. Um,
Uh,
but let me see here. So yeah, but could you maybe check if is there anyone else in that Zoom? Do you know? Maybe
yeah,
there's someone else hopped in there really quick. Maybe they're just
yeah.
clicking an
I'll
old
step
link.
out.
It's unfortunate.
I'll be right
That would
back.
be great. Thank you.
I didn't see it.
Hey. Okay. Yeah. All right. Good. That's good. Okay. Cool. All right then. We can just kind of start with the first one. So these are 13. Well, I'll read the message she got. When it comes to programming interviews, there are several algorithms and data structures that are commonly asked. Here's a list of 13 that are often considered important. And they are binary search, array and string manipulation, linked lists, trees and graphs, hashing, sorting algorithms, recursion, dynamic programming, breadth first search, greedy algorithms, two-pointer technique, backtracking, and bit manipulation. And so that's just to name them. And we can go over those and we can kind of start from the top. Um, I've heard, unless you are applying to FANG companies, it depends which, and maybe the seniority and maybe the position and that you're applying for. Not many places are going to ask you dynamic programming, although they might. Uh, but a lot of them are more focused on arrays and string manipulation and things like that, just because that's probably going to be more applicable to the job or the position. Maybe it's more applicable to a lot of positions. So possibly. Anyway, so we can just start. Uh, how would you describe a binary search?
Uh, so binaries are one of zeros. We will be looking at, let's say, a single letter. I imagine. And seeing what its binary code, and then change that, we would change which would change what character it is. Um, I think it would also be useful, let's say, if in MySQL you converted a PNG into binary to store it, let's say.
Hmm. Okay. Okay.
And
I
then you
Go ahead.
try to match the exact picture. You basically convert the image again and try to search it in the MySQL. I think that's what I would use it for.
Okay.
I don't know
I
what
think
applications, or I don't know if that's what it means by binary search.
okay. I think a binary search. I mean, binary is, 1 and 0, so it's just either or. So I think
Oh,
binary search is just uh, yes or no. It's typically searching through an algorithm or searching through something, and you are. It's kind of like a sort. I think it's a little similar to binary sort. I'm looking it up right now to maybe to get a better answer.
I was overthinking it then. Okay,
Yeah, well, I mean, you're right on some of the things you're saying, whereas you store PNGs and you store, JPEGs um, as binary, right? You can store them as binary arrays, but and then you would search for binary. But as far as an algorithm goes, hey Chris, um, as far as an algorithm goes, I think it's essentially like a sort, uh, although maybe there's a difference between those two. But you're searching one and then another, and then you no, 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 or no, yes, no, yes, no, yes, no, no, yes, and then so you can find the one that you're actually looking for. So I'm searching that right now, and yeah, I guess I'd just say it's like flipping through a book, and you're looking for a specific page, and you flip through, and if you know that the page is less than the page you're on, you're going to look on the other side, and then if you open those pages and it looks, the page is more than that page, then you're going to keep flipping back and forth between pages until you land on the right one. I think that's it.
I see. Okay.
Yeah. Let's see. And it says on first Google, it says binary search is an efficient algorithm for finding an item from a sorted list of items. Yeah, that's important. Sorted list. It works by repeatedly dividing in half the portion of the list that could remain or that could contain the item until you've narrowed down the possible location to just one, which I think that's correct. Correct, Google. Good job. Yeah. Okay, so next one, array and string manipulation. That's kind of a broad algorithm description. I'm not really sure you'd necessarily call that one. Uh, this sliding window, we could talk about that too. You want to give it a shot, Chris? Do you want to? We're trying to describe out loud what the initial inherently like what an algorithm does, or what these different types of algorithms are. This one seems a little broad though. And at the end, if you guys want to, I think we could try an algo together and try and solve it as a group.
Okay. It's been a minute since I've used that part of my brain.
Yeah. Your mic's a little
Um,
low, just so you know.
oh, sorry. Is that better?
Yeah, that's better.
All right. So you're all just talking about I mean, binary search. I kind of remember doing binary searches. I don't remember what I did to do that though. It was
Mhm.
just kind of like a for loop and then like going through it to see if this matches this, then that's our answer. If this doesn't match this, then that's not our answer, kind of thing, and keep going.
That's
Um,
that's kind of it, yeah.
like I can't think of anything for array and string manipulation other than like maybe con is it no, concatenating is not the word I'm looking for. Like splitting, like the
Yeah,
split function.
there's lots of things you can do to manipulate, strings and arrays. Thing is, in JavaScript, uh, I think strings and arrays are immutable, which makes it, just a little bit annoying, and maybe not annoying, a little more complex than you'd think, because it's like sometimes to manipulate an array or a string in JavaScript, you have to create a copy, and then you have to manipulate the copy, and or create instances or variables of copies parts of the array, and then add them back together. Um, so it can be a little. I think it's not just. It may not just be JavaScript either. It's uh, some other languages, and I think there might be a good reason for it. Otherwise, they certainly wouldn't be doing it. So that would be interesting to know. Okay. So linked lists. What are linked lists? We're just trying to explain it to someone if they didn't know what coding was.
I mean, linked list, is that like the queues?
Yeah, there are queues. It's used for queues. Yep.
I can't remember. The only thing I remember that's popping in my head is you've got the queues, like first one in, last one out, and then first one in, first one out. I don't remember the difference.
Yeah. Well,
Let me see if I can find
that's
it.
kind of that. I'm not sure. Yeah, kind of. Do you want to give it a shot, Franco?
Um, Scarcely remember. So it's it's almost there. I just remember the picture from the platform of the train.
Mm.
I
Yeah,
just
train
remember
simulator.
that the first card and the last card are the most important to be able to access the information inside of I think these are called nodes.
Yep, they're called nodes.
Yeah, I haven't
Mhm.
worked with those in a while.
Yeah.
Uh, yeah, I don't remember much about it other than that. It's like a full train, and you try to manipulate like this card is gonna go on this space here.
Mhm.
Um, I think that's what linked list is. It makes it easier for you to manipulate uh, cards to go somewhere else. In other words, let's say regular array 0, 1, 2, 3, 4. You want to move the information from 0 into number 2, let's say.
Mhm.
I think that makes it easier. Am I correct? Or something like
Uh,
that.
it's a little different, but you got kind of like the purpose of it, and like so. And I'm not 100% expert on them, but it's essentially like what the node is. The node that you're referencing, right? Like it's an object, and it has a value. It's holding on to a value, and then it has a reference to another node, and that reference to the next node is the list. And so there is the link, right? And it will also have a reference. It may have a reference to its previous one as well, but it may not, right? So what links it is that it's a variable or an object with a value in itself and then a reference to another object, and that would be called the next. Like object.next or runner.next or head.next or something like that. Um,
Mm,
and so they're linked up by a reference to the next one. And that's why people say like YouTube videos is good because like you watch a YouTube video, it's holding the content of that video and all that information. But what it also has is it's if it's on autoplay, there's a next video that's going to be queued up. Whatever video that is already linked. That's its next, right? And the video
okay.
it came from would be its previous.
Hmm.
So it's just an object, and then it's almost like a postage on an envelope, right? Like it's the sender, it's where it's going, and then there's the envelope itself, and it's holding the contents. And so that's basically it. It's just an envelope, where it came from, and or what's behind it, what's in it, and where it's going.
Okay.
And then
Uh, I get it. So
yeah,
the purpose of it, uh, I'm guessing this is Java or JavaScript. I can't
this
remember.
is it's a data structure, so
Oh,
it's
okay.
can be built in any language. It's just a
Okay.
way of referencing different different objects or values, just like how inside of an array has indexes, right? Every point is an index, and that's just its location in a list.
Mm,
Well, this is a list, but it's a loose list. It's loose in the sense that if you change a reference at any point to any other point in the list, then that's the new list, right? Like, so if you have, we'll just say three nodes, and they go from 1, 2, 3. If you change the next node value to 3, 1 goes to 3 now, and 2 is just gone, unless its reference is previous or something like that, because it's you've changed the reference, so it's out of the link.
I see.
So it's weird, because if you think about it in terms of arrays and things like that, it's all contained inside of a single, object of or an array. But linked lists are individual nodes that just reference each other, but they don't, they're not part of a single unit or something. Sort of like binary trees. Binary trees are like that too, except linked lists are direct references. But binary trees have different rules for how they work. Anyway, let's move on to the next one, having said that. And I don't know the answer to one of these, but trees and graphs.
Yeah, each tree has like the data structure, like the old school Christmas tree. So you've got like this branch and this branch, and then if you're on like the A branch and you want to access the B branch, then you have to like work your way all back up to the top and then down back the B branch. That's what I remember about trees. It's a little bit harder to get data, like
Yeah, it can be quicker in some instances.
yeah, like if you know you're gonna be on this A branch, then it might be easier. But if you don't know where you're supposed to go, it might be harder to find. So that
Yeah.
might not be the best
A
data
tree is
tracking to use.
definitely like, it's like the best notation, or not notation, but like way to reference it and visualize it or symbolize it. You could also think of it like a web, it kind of goes like a web from both sides. And you start in the center, right? You start at whatever value is the central value. And then for every node has a value. And any value directly to its left will be less. Anything to the left of that value or behind it will be less than any given node. And any value to the right will be more. And that makes it binary. And that way you can search through larger numbers or larger data sets by going through and looking for left or right, or more or less. Whereas if you're going through an array and you're searching through an array, and let's say it has 1 million indices, then you'd have to go through it if you were just doing a straight search through it, or not a binary search, right? But with a binary tree, there's fewer steps to find the data that you need. So the next one is hashing, which I actually don't understand necessarily.
Yeah, I don't. I got
Yeah.
nothing. I'm just looking up the graphs part of that last one. I don't
Oh,
think
yeah,
I
yeah, yeah.
learned any of the graph stuff because this data structure stuff for graphs it looks like a matrix of just information
Yeah.
and it's all connected.
Hmm.
But even though it's not connected, it's connected. It's
Yeah.
weird.
We do sorting algorithms. We kind of did sorting algorithms. There's binary sort,
Like bubble sort, right?
Yeah, bubble sort. Yeah, and then there's other algorithms too. Bubble sort being kind of like the brute force method. Do you guys know next? I mean, we could talk about sorting algorithms instead. In the example given here is, imagine sorting a deck of cards, like arranging them from smallest to largest. Yeah, that's kind of like that. If I was going to explain sorting algorithms, I would just say changing the position of data in a list depending on its value in relation to other values in the list, right? Which is exactly like sorting a deck of cards. So recursion. This is an interesting description that they've given. It's not how I would describe it. Do you guys want to describe it?
Nope. Franco, do you know recursion? I think of recursion like Inception. Do you see that movie?
Yeah, it's like that.
It's a dream in a dream, but you're still in a dream.
Kind of. It's a little bit, yeah, it's a little funky. It can take a little once you understand it, it's like, wow, that's cool. That's very cool and interesting. But until then,
I still have not made it to that point yet with recursion.
Microsoft has an excellent video on it, on recursion. They really break it down and explain it well. Franco, did you want to give it a shot or?
Recursion?
Yeah.
No, I don't remember that actually.
So okay.
Mhm.
So the description on the list says it's like solving a puzzle piece by piece, where each piece is a smaller version of the whole. That could very much be true. I don't think of it that way. That's not essentially how I understand it. Recursion, essentially, the trick about a recursion that I didn't understand is that it sets things up in a queue or in a stack, right? The stack um, is where operations that need to be performed get placed, right? And if you have too many operations before they can finish, you get stack overflow, right? But with recursion, you're giving the program tasks to do, and it's putting them on a stack, and it's stacking them and stacking them and stacking them. And then once it hits the I can't remember the terminology, the end condition, essentially, the terminate condition, then it starts from the top, which means it kind of goes backwards. Whatever the last thing on the top happened, that happens first. And then it executes the top one, then the next one, and the next one, and the next one, and the next one, until it gets down to the very bottom, and then it ends. So it's sort of like if you were stacking cards and each card was a action to perform, a command or something like that, a function of some sort. And then you stack them up, and then you pull them off the top, and then you do. Then you do them all. So that was the trick. The trick was that you're programming it to run in reverse. If you want to think of it, I think that's maybe how I think about it, but I still don't perfectly understand it. But I think that's why it's called recursion.
So is recursion like a data structure also, or is it like what I have in my mind is like recursive functions?
Yes. Yeah. I was gonna say yeah.
So it's mainly like just where the function like calls itself, right?
Yes, that's right.
And then that's how you work. Okay.
Mm-hmm.
One day it'll get there in my head.
Well, there you have it, because that was the part I didn't mention, and that I think that's actually probably the fundamental part, is that it calls itself. The function calls itself inside of itself, and that, of course, can happen endlessly unless you have an end condition. And so the first thing you do in recursion is you put down your end condition, and then you would have it call itself, right? So almost like a loop, and you would say like if value equals 0, return, unless but if value doesn't equal 0, call -1 function on 10, right? And then it will call, if it's the -1 function and the value is 10, now so is the value 0? No. And then it will reduce 1, and then it'll be 9, and then no, ding ding ding, except that instead of just being a loop going forward, it's calling the function every single time, or it's putting all these functions on a stack, and then once it hits 0, it will it'll cancel, it'll go them all at once.
That made it a little easier in my head.
Yeah,
'Cause
right.
it is. It's like there's like the for loop. Like, why wouldn't I just use a for loop? But I mean, that's the only way I've been able to understand a recursive function the way you
Right.
just said it.
Well,
Like
yeah,
any
because
other recursive function I've seen has sent me in a tailspin.
sure. Well, the thing is, you might not want to use a for loop because a for loop would be essentially referencing a value such as it's probably like an integer, right? Uh, I'm assuming it's probably an integer. And I don't know if you can reference strings. I don't know. I don't. That seems like a really basic question. I never just bothered to learn. Like, can you be like, if string equals stop in a for loop, have it stop? I don't know. I don't think that's the case. But imagine anyway. But you can do that in recursion.
Oh no, not ready to imagine that yet.
Oh, okay. I'm sure you could do that in recursion, right? You could
It's got to be possible though, right?
yeah, you could have four variables that are just letters, and then you could add them all to a string, and then you could check string against like you could have the letters to spell stop, S-T-O-P, right? And you could put them all into a string, and then you could check if that string says stop. And if as long as it doesn't say stop, you keep adding the letters in, and then once the string has enough letters that it says stop, the recursion ends.
Oh, that just made me think of all those password crackers people hook up to like, those like little barcode things on the door that they're trying to break into in movies.
Oh yeah, yeah. Right. Little sonic, not right, quite a sonic screwdriver, but yeah. Okay, so yeah, recursion's interesting. I've not run into instances when I've needed to use it in anything I've been building. I've been building, full stack applications, and mostly referencing libraries and things, but I haven't had to use recursion to solve any problems. Okay, so dynamic programming. Uh, I don't really understand dynamic programming, so I don't really know an answer to that one. Do you guys?
I don't know. I've never heard dynamic programming. Is it just
Uh,
like making a cheat sheet?
Maybe. I only say that because um here do you have something you want to say?
I don't know. It doesn't make sense. Like preparing ingredients in advance, isn't that what you do when you first, before you start following the recipe? I mean, the cooking part. I don't know.
That's
Doesn't make sense.
right. When you said cheat sheet, I was like, I don't even know what it means, but on this it says picture it as optimizing a recipe by saving intermediate steps, like preparing ingredients in advance, right? So I guess that's kind of not a cheat sheet, but you have what you need beforehand. So maybe you're you're building pre-built functions into your function. I guess dynamic, maybe it's referencing functions.
Hmm.
I don't know, actually. Let's just Google it.
Yeah, Google has something different than what I was
Oh,
thinking.
no, let's be 2024. Let's ask ChatGPT. Mm-hmm. Uh, please provide a simple description of dynamic programming. Dynamic programming is a problem-solving technique used in computer science and mathematics to optimize the solution of problems by breaking them down into simpler overlapping subproblems. Okay. Instead of solving each subproblem independently, dynamic programming stores the solutions to subproblems in a table and reuses them when needed. This approach helps to avoid redundant computations, leading to more efficient algorithms. Dynamic programming is commonly used in optimization problems where the goal is to find the best solution among a set of feasible solutions. Okay, so it's sort of like, it almost sounds like building an application for solving an algorithm. You're building a little algorithm, application algorithm that solves algorithms inside the algorithm.
Sounds crazy, but it is helpful.
It just
Like
sounds a little
making
more Yeah.
One problem, 15 problems sounds crazy.
15
But when that one
small
problem
bites.
is insane,
Yeah.
sometimes it is helpful.
Greedy algorithms. Think of it as making the best short-term decision at each. Oh, I was just reading that out loud. I don't. Do you guys know what greedy algorithms are?
They're all greedy.
Yeah. Think of it as making the best short-term decision at each step, like selecting the ripest fruit first. Hmm. Okay. Maybe solving the biggest chunk or something. Hmm.
I have no idea. It looks like a tree and a graph mixed together.
ChatGPT says, greedy algorithms are a class of algorithms that make locally optimal choices at each step, the hope of finding a global optimum. In other words, at each decision point, a greedy algorithm selects the best available option without considering the overall problem. This choice is based solely on the information available at that particular step. Okay. The key characteristic of greedy algorithms is their myopic view, focusing on immediate gains without considering the potential consequences in the future. Despite their simplicity, greedy algorithms can be effective for solving certain optimization problems. However, it is important to note that their approach doesn't guarantee a global optimal solution. In all cases, an optimal solution might be missed if the algorithm doesn't consider the big picture. Okay. Greedy algorithms are commonly used when the problem exhibits the greedy choice property, meaning that making the locally optimal choice at each step leads to a globally optimal solution. Examples of problems where greedy algorithms are applied include minimum spanning tree, Huffman coding, and interval scheduling. Okay, interesting. Almost sounds like when the nature of the problem is to always take the greatest optimal solution first, that would be called a greedy algorithm. You call it a fat optimal algorithm. I don't know, something like that. The two-pointer technique. Do you guys know what that is?
Mm-mm.
I feel like that was used for the nodes, right? And like the lists and stuff.
Um,
Like
yeah.
the reference one points to the next node, right?
It's a little bit different.
Something like that.
That is how the nodes work. Two pointers is essentially you establish two variables that have a reference to what you're trying to sort or the problem you're trying to solve, and then you update those variables to solve the algo, I suppose. Like highest and lowest, and then that would be two variables, and then you would update those, and they would bring together to solve an issue. Okay, and I don't know the next ones. I know I've seen bit manipulation used as a solution. Do you guys know what backtracking is?
Yeah, I do not.
Let's see. Oh, wow. Backtracking is a general algorithmic technique used to find all or some solutions to computational problems, especially in combinatorial optimization and constraint satisfaction problems. The basic idea behind the backtracking is to incrementally build candidates for a solution and backtrack when it is determined that the current candidate cannot be completed to a valid solution. Huh. Okay, so you're almost finding dead ends.
That's weird, right?
Yeah. Here are the general steps involved in the backtracking algorithm. Choose. Make a choice for the next step toward a solution. This involves selecting a candidate for the solution. 2. Explore. Move to the next decision point or subproblem and recursively explore it. This step involves making further choices and progressing towards a potential solution. 3. Backtrack. If the current candidate does not lead to a valid solution or exhausts all possibilities, backtrack to the previous decision point and explore other choices. And 4, repeat the process until a valid solution is found and all possibilities have been explored. Okay.
Sounds like version control.
Yeah, it does sound like version control. Choices. Okay, yeah. Yeah, that's actually exactly what it seems. Okay.
I mean, that seems like the basis of coding in a nutshell. You do something, it doesn't work. You start again, you do it,
Go back, yeah.
maybe it works, and then you keep
Hmm.
going down that path until it doesn't.
Yeah. Backtracking is particularly useful for solving problems where the solution is represented as a sequence of choices, and it allows the algorithm to efficiently explore the solution space without explicitly constructing the entire space. I see. Examples of problems solved using backtracking include the n-queens problem, Sudoku, and solving mazes. Okay, yeah, that totally makes sense. The technique is widely applied in areas such as artificial intelligence, optimization, and constraint programming. Cool. Interesting. Sounds like you just use an if statement and say, if this, then return here, depending on that. Possible. You have to set up a checkpoint. So, and then bit manipulation. And this is one I've seen, but I don't quite necessarily understand it. You guys have a take, or if you understand it, let me know.
I've never seen bit manipulation. Or
Okay.
maybe I have and I just don't remember. But it is not in my brain.
Ooh,
Maybe like a toggle, like you press the button one, you press the button again, it's now 0.
yeah. I think it's because certain values, such as letters and even just numbers in a sense, have bit references. Like 1 and 0 have bit references, right? But I think 2, 3, 4, and all that have that too. And I think if you manipulate that, it will change things. Bit manipulation involves the manipulation of individual bits in a binary representation of data. In computing, data is often stored in binary format, where each piece of information is represented using combinations of ones and zeros, bits. Bit manipulation allows for efficient operations at the bit level, providing a way to optimize certain algorithms and perform low-level operations. Here are some common bit manipulation operations. Bitwise AND performs the AND operation on each pair of corresponding bits. The result is 1 only if both bits are 1. This is a little bit, yeah, I'm going to put this in chat. You guys can read this one, because it's almost a little bit
I
complex.
think I get it.
Oh, message too long. Here we go.
I see. So, in other words, it sounds like it's comparing to the different. So let's say we're comparing capital N versus lowercase n. When we convert that to binary, ones and zeros, one of the bits inside, because it's 8 bits, is going to be different. Um, I don't know if bit manipulation means we compare a specific position within the 8 bits, or we compare all of them.
Yeah. That's a good question. I don't know. I'm not 100% sure.
But it definitely sounds like it's comparison.
I do like his so this was sent to Melissa by someone, and I don't know who necessarily. So I don't know if it was a guy or a girl. Says, remember, each algorithm is like a magical spell in your coding spell book, ready to be used when needed. And I totally love that, and I totally agree. If you want more details on any of them or need them explained in a different way, just let me know.
That's cool.
Yeah, and I like that. That's great. Cool. And so again, Chris, before you got here, I think we said, or I said, that what I've heard from people is most common in coding interviews for the majority of positions, I think, is strings and array manipulation, reversing strings, and things like that. Even FizzBuzz. And in my mind, yeah, I mean, it's like could you, manipulate this binary tree and this, I'm a little, or, they're going to be like, do a graphing algorithm, and I would feel like
Oh
I couldn't,
shit.
or something like that. But I think that most places might be looking for something that's more applicable to front end, or something at least, you're going to be using more often. And if you really need to, depending on what you're building, I'm sure there would be more complicated algorithms, and maybe just as a way to sort candidates. If they have a large number of qualified candidates, they would say who's got the best dynamic programming. But just from some of the things I've heard.
Well,
So you
I
guys
have
want to?
yet to hear back from any interviews, so
Yeah.
so I'm just learning as much as I can in the meantime. Well, when I can.
Hmm. Have you
That's
been
what I
getting interviews?
No, no.
Ah,
I've heard back from one person, and it was a sorry, we've filled the position. But I counted that as a win because I finally heard back from somebody.
yeah, right. Yeah, they're talking to me.
But no,
Okay.
like I'm kind of burnt out at the moment. But
Hmm.
when we were in October, that was a fun little project we were doing. So I was like in the zone then. I got to
Yeah.
get back in the zone now.
Did you do? Were you on the Honey Devs
Yeah, I
team?
added like an image or something. That was it.
Oh, well. Either way, yeah, it was fun. It was good.
Yeah, it's kind of fun hanging out with people. Like chatting with you guys definitely gets my motivation back on track a little bit more, so it's very helpful.
Yeah, it's just fun. Let's do an algo, and we can, doesn't have to be crazy or anything. Okay, but we'll figure it out. Um, reverse words in a string, that's medium. So we'll just do something. I like can place flowers. This one is pretty good. I did that one. There's the last one I did. So, um, kids with the greatest number of candies. There's that one. The greatest common divisor of strings. This one's pretty good too. This one's a little tricky. I have to do that one again. Which one do you guys want to do?
The hardest one. I've been getting a lot of really difficult ones.
Okay. This one's tricky for me, so let's do this one. And I'm going to get rid of the answers. Don't pay attention to the man behind the curtain. There we go. Okay. Okay, so for two strings, S and T, we say T divides S if and only if S equals T plus T plus T. T is concatenated with itself one or more times. Given two strings, string 1 and string 2, return the largest string X such that X divides both string 1 and 2. And string 1 and string 2 consist of English uppercase letters, so no breaks, no dashes or anything like that. String 1 length is always equal to or greater than 1, and string 2 length is always less than or equal to 1,000. So string 2, they could both be 1, but neither one is empty. Okay, so let's just talk it out.
Yeah, because the main thing I can remember is what you said about string 1's length and string 2's length, and the rest
Oh,
of it,
well, let's do it again. We're at the top. For two strings, S and T, we say T divides S if and only if S equals T plus T plus T, or to any number of iterations.
So how does a string divide a string?
So can you see my screen? So it says over in example 1, right? String 1 is ABC, ABC. String 2 is ABC.
So it's like gotta be half for that example,
Yeah,
what it's dividing it by.
return the largest string x such that x divides both string 1 and string 2.
So when it says divides, just means cut it, or no? Because example 2 and 3 is different.
Yeah, so if you look at 2, right, string 1 is a b a b a b, and string 2 is a b a b. So x, the thing that we are trying to return, which is a separate variable that we're going to determine, divides both of them equally or evenly with ab. That would be the largest string that divides equally for both of them. It's their lowest common denominator.
Okay, but what about example 3?
So example 3, string 1 is leet, and string 2 is code, so they
Oh, so
have
there
nothing.
is none. Oh, gotcha.
Mhm.
So you've got to see the similarities and see where the similarities end.
Mhm.
Ooh, this is yeah.
Mhm.
So we're gonna have to keep track of each string and compare them along the way, right?
Yeah. I'm glad we're doing this one because this one gave me a little trouble. And the ones that give me trouble, it's always a little frustrating when I go through and I look and it's the answer is like one line of code, you know? But so let's see.
Yeah, because in my head right now, I'm seeing like 100 lines of code at least.
Right. Yeah.
But yeah, once you get it, it's easier. But I know what you're saying. Okay.
Mhm. Well, the first thing we're gonna do is let's just say we can create a variable to hold and return the result. We know that. That's okay. So we could say let x, which is what we're returning, equal an empty string. So it's equal to an empty string. That's fine. So the next thing we need to do is in all these examples, string 1 is bigger than string 2. Uh, hmm.
Do we start an if statement here?
Yeah, use an if statement.
String 1 could technically be bigger than string 2 because the constraints would like allow it, right?
Yeah, yeah, it could.
I don't know. We don't have an example of that though, so we can just say we don't have to worry about it, right?
Hmm. So I'm thinking like we can assign the value of the first index. Well, let's find the shortest one, right? Because let's find the shortest uh, string, and then we'll operate with the shortest string because it's going to have to be able to divide them both anyway. So let's say find the shortest string, the shortest. Oop, say let shortest str equal. Well, here's where we can use an if statement there too. I will say if you find first
Oh,
string.
wait. Okay,
Yeah.
so if string 1 is bigger than string 2, then you can just swap them, right? So like,
Yeah.
is that what you're doing right now?
Yeah.
Cool, cool. Okay, my brain's caught up to where you're at. I got excited.
So string one dot length str2 dot length. And we'll say str1. Else, let's just say short string str2. Okay. And now I think what we do is we look for the, like, for instance, right? If the first index, or if string one was just a, right? And string two was just a. The shortest or the largest string x. Oh, so it'd be the largest one. Well, if string one was a and string two is a, the answer would be a. It would return a, right? So if they were both one in length and they're the same character, then it would return that one character of that length. Because that would be their common denominator.
It would be the common denominator. So they're both a, you get a, but the if statement. So if a, so if 1 is greater than 1, then we let shortest string equal string 1, else it would go to else, so short string would equal string 2.
Yeah, I was just thinking that if we knew what the shorter one was, then we could start with that, because I was thinking of iterating over the string, and I didn't want to iterate too far over a very long string.
Well, yeah, it makes sense to know which one is shorter, because then you just start with that one, and then if that matches the beginning of the next one,
Yeah,
then that's your common denominator, right?
we can just go up here and say let short str equal, no, just let short str. That's fine.
Do they need to be different names, or
It's just one name. I'm just declaring variable here, and then I'm setting it conditionally depending on which one is longer.
okay?
Oh, and I'm doing it backwards. There we go. If string.length is less than string.length 2, string 1 is shortest, else string 2 is shortest. Okay. Hey, Madeline.
Y'all, how's it going?
Good. So then I think, so if string 1 is just the letter A and string 2 is just the letter A, their common denominator is A. If string 1 is A and string 2 is AA, their common denominator is both A, right? But if string 1 and string 2 are both AA, double A's, their common denominator is double A's, AA. So we're going to want to find a point where their characters don't match. If like an example one, if we were iterating over A, we'd compare the first index 0 to the second index 0, and string index 0 of string 1 is A, index 0 of string 2 is A, right? And so if they match, then we would add that to X. And if string, then B, we'd repeat it with B. And if they match, we'd add that to X, and X would be AB. And then repeat for C. And then string 2 would be null. It'd be out of range. Which we want to make sure we don't throw an error. And then we would check, then we would have X. We would know that ABC was their greatest common denominator, but whether or not they're evenly divisible is the question.
So can we throw an and in the if statement? Like if string 1 dot length is less than string 2 dot length and string 1 equals string 2? So like if it was AA for string 1 and AA for string 2, that would return like AA for
That
X,
would be
right?
that's a good check to do right at the top. It's just to say, check if strings are identical.
Because if they're not identical, then we're going to have to, I don't know, it's probably more complicated in my head, but what I'm thinking is copy each string letter by letter and match string 1 to string 2 until it doesn't match anymore. But if it's identical, then that would be an easier check right off the front.
Yeah. This would, I mean, we don't have to even sign it to a thing, so. This would check they're identical. So if str1 equals str2, x equals str1, return x, because they're identical. So they're the same common denominator, right? Say else. No, we don't have to put an else there. That's just a check immediately. That's fine.
So I'm kind of thinking like the bubble sort thing in my head, but I don't know if that's the best use case here. Like how you were saying the bubble sort copies like the array, like we could copy the string. How would we tell if each string is, oh, if each string is a different length, then that's when we go into this one. And then I mean, would we have to check essentially each letter versus each letter, right? I mean, we
Yeah.
probably have to, right?
Example 2 is what kind of throws you off, or throws me off, is A, B, because if we were just referencing each index, right? Say is A, we go A, okay, good, continue. B, B, continue. A, continue. B, B, continue. But the common denominator is A, B. So,
Oh, yeah, it would be AB, AB, right?
it wouldn't be A,
The
B,
way
A, B,
the way
because
I was
that's
thinking about it.
it's too big, yeah. The common denominator is A, B. So,
Or ABC, ABC equals ABC, and then that, the output is ABC. Maybe it's just each letter is used once or twice. It's used once in both strings.
Mhm.
Because ABC is used once in string 1, and then ABC is used once in string 2, so that's the output. And then AB, AB, AB in string 1, and then AB, AB. So AB is the output on that because AB is used once at least. And
Hmm.
I don't know about that because, well, yeah, because in LeetCode, there's no letters that are overlapping in both of them. So maybe it's just which letters are both strings using.
Yeah. Dogs are whining at me. Hmm. Do you have any idea, Madeline? You got an idea, Franco?
Oh, I really don't. This is a little more challenging than I guess my level. So
Okay.
taking it in. Thank you for asking.
Yeah, yeah. Well, if you guys want, I've seen the solution to this, and it's infuriatingly simple. Uh,
Don't do it.
no, I mean,
Don't do it.
I'm a 20-minute rule guy. I think 20 minutes is a good rule. But that's usually when you're stuck, right? It's like when you're stuck for 20 minutes.
It's fun trying to figure it out with people, but I do have it set up on Google so I can click in just a minute and find out too.
Yeah.
Like
Right, right, right. So
I'll say some stuff out loud, I guess, before you give out the answer. All right. So the first text up top throws me off. For two strings S and T, we say T divides S. So we use whatever T is to divide it, but then it says that we have to concatenate with itself one or more times.
mhm.
So for example, if we take example 1, ABC, after it divides into ABC, ABC, meaning string 2 divides into string 1, we have to add one more time ABC with ABC, concatenate them. And then we check, I guess we do a check if they both equal, string 1 and string 2 equals. And if it equals, that means do one final check there and stop. Or maybe do nothing if it checks that they're both equal. So basically stop exactly when they're both equal. But then example 2 throws me off because, like you said, it outputs AB. It's
Mhm.
like it's removing things instead.
Right. It's the lowest common denominator. It's the shortest string that they have in common.
Okay.
Mhm.
concatenate AB, AB and string 2, it would be string
But
1
then
would
again,
be AB, AB, AB,
I'm sorry.
AB.
Go ahead.
And I heard Chris talking. You
Oh,
can go ahead,
yeah.
Chris.
I was just wondering if what you were saying is, for example 2, like where string 2 with if it was going to concatenate itself, would it be like 4 sets of AB in string 1 instead of just the 3?
Yes, if string 2, for example, 2 concatenates, it would be 4 ABs, which is not equal to string 1.
Right.
Gotcha.
So that cancels out.
Yeah, I wasn't even paying attention to the concatenation thing up top earlier.
That's just, I mean, it doesn't have
Blew
to
my mind.
concatenate. It's just saying that it's just another way of explaining the first part of the sentence.
I'm ready for the answer.
I mean, it technically will concatenate, but yeah.
Mm.
I was thinking of one other check that we could do, and check. I think we'll get to the solution pretty soon though. Check if so like if one of them is a odd number, right? Like it's one of them is 5, and they don't have the same first character, then I don't think it's possible for them to, well, if they don't have the same first character, then it doesn't matter at all, right? Doesn't the first character have to be the same? Yeah, the first character has to be the same. Otherwise, it's not divisible, period. So the first character has to be the same, and I mean, then the second character has to be the same.
If there's a second character.
It's, yeah. It's just finding a point. It's finding the break point. That's the only trick. Finding the break point for comparison. That's where you have to find widths when it's divisible. Can't hear you, Madeline. Still can't hear you, Madeline. Sorry.
Oh, sorry, I actually didn't say anything. That was some background noise. Excuse me.
Oh, okay. Okay, gotcha. Okay. Well, the first character has to be the same, so this, unless when they stop being the same, that's the question. When one becomes null. So here, let's go over it. I think we kind of gave it a shot here. Let's check it out. We'll do JavaScript. 60,000 views, 66,000 views. Super easy solution, fully explained with C++, Python, and Java. Well, we're doing JavaScript. If you guys have a different one you want to do, we can do that too. We'll do JavaScript here. JavaScript solution, 3 lines, 95% runtime, 100% memory usage, 100% memory usage. Explained with intuition and approach. Ultimately, any of these is very fine. Java, very, very, very easy to understand solution with no video, with video explanation. I don't even know if I want a video explanation. Let's just click the top one. Greatest common denominator of strings. If string 1 plus string 2 does not equal string 2 plus string 1, return. That's a good check right at the start there. So if you change their order, if you add them together and they don't equal each other in the exact same order when you flip them, they don't count. Like they're not going to be, it's not going to be right. Right? They don't have a common denominator at that point. st1 plus st2 doesn't equal st2 plus st1. They're not going to have a common denominator.
How is it different?
If like ABC plus ABCD. Well, no, that's not right either. Well, yeah, no, that is right.
Oh,
that is right.
It's not dot length, so it's not the number of letters in the string or whatever, right?
No, it's the sequence.
Okay.
Yeah. All right, so that's good. That's a really intuitive check. That's really good. Then otherwise, it's and let's just write it. I'm gonna write it just so I can write it. Plus str2 does not equal str2 plus str1. Return an empty string, which is their common denominator. That's good too. That's good to know too. Well, let's just say const GCD greatest common denominator equals, it's going to take in A and B as a function, This is a ternary operator, declaring an anonymous function here. Well, I guess the function is greatest common denominator. That's the name. It's going to say if 0 equals b, see that. So yeah, there's a this is some syntax. How does this work here? I can't remember. Oh, this is recursion. It's going to call itself inside of the function. That's what's going on.
This isn't recursion, is it?
It's calling the function inside of itself here.
I thought that was like or. Like so with the ternary operators, if 0 equals b, then you return a, or then you
This
do
is
or,
else.
because it's calling GCD again.
Yeah, this is else.
Oh, it's else, not or.
Mm-hmm.
Okay. Yeah, then GCD again though. That is definitely recursion.
This is what I'm not getting. The A here. So let's
So is
see.
A gonna be like string 1 or string 2?
Yeah, these are the parameters, right? Oh yeah, it is. Okay, so this is the function. So he's putting in substring of 0. He's calling, so this is the function he's writing. And then here's where he's calling the function and returning the result. So I think this says the function greatest common denominator takes in two parameters, a and b. If b equals 0, return a. Else, call greatest common denominator with b as the first parameter and the result of a modulo b. Which will be a whole number or not. Oh, well, no, it'll be, what will it be? It'll be a lesser number. Oh, that'll reduce it. So I think what this does is, if we can check it with Chat GPT, which is a good thing to do. I think what this does is it takes in the strings. And the substring is a command, I think. Oh, it takes in the length of the strings. This one's listed as easy, but it seems a little complex. And I think we could write it a little easier here and say like let x, or like you say like let result equal well, let's say let result, or let result equal this. And then we would say return result. just to make it, that's a little, you know, the way he wrote it's faster and elegant, less to write, but still. So it's going to look up here, right? And it's going to say if string 1 plus string 2 does not equal string 2 plus string 1, then they don't have a common denominator. They won't, because they're not going to be even numbers, or they're going to be different letters or something like that. They're going to be, there's not going to be a common order throughout all of them. So they have to be reversible. So that's it. So are they reversible? If they're not, then return nothing. If we pass that, then we're going to get into a function. Greatest common denominator takes in 2 parameters, a and b. If b is equal to 0, then return a. Else, run it again, and it's going to take in the parameters of b and the result of a modulo b. And when you do modulo, it returns the remainder. So if do you guys understand modulo?
It's just divided by, right?
Well, it's divided by, but it's gonna give you back the remainder of so you know, it's like 5 divided by 2 is 2.5, but 5 modulo 2 is 0.5. It's going to give you whatever's on the other side of the decimal. If there's a decimal, it's going to give you the decimal. But if it's like 4 modulo 2, it's going to give you 2. 2 is the remainder.
So it divides it, and the number that it got, the decimal is the module if it wasn't a whole number.
Right.
Oh, I actually didn't know that. I knew
It's
how to
gonna-
use module to certain things, but I didn't know that.
Yeah, it's going to give you the leftover. So that's how you can use it to flip, you know, between 2 and 1 and things like that. So I think in this instance, right, if this is length 8 and this is length 2, and they pass this test, right, then it'd say, okay, is 2 equal to 0? It's not. Then, is that right? Is 2 equal to 0? No. Then 8. What? I don't understand. I'm not thinking about this correctly. Oh. Oh, it'll return this one. It will return this one. If once the second one is equal to 0, it will return the first value of the parameter. Once the second Is the second parameter equal to 0? If so, return the first parameter. If not, recursively run this again, and we're going to put the second parameter in, and then we're going to put, and for the first parameter is going to be string 2, and the second parameter is going to be the modulo of string 1 and 2. That's a little complex to be an easy one, simply because it's kind of like, maybe this is just a complex, or I don't know, I just wouldn't consider it easy, but it's pretty good. It's very smart. Do you guys get it? I can't even put it to words necessarily. But we can walk through it. So let's walk through it.
Yeah, like maybe line 9 I get, and then
Okay.
beyond that.
So we'll say line 9, and we'll say this. If strings aren't reversible, aren't the same backwards and forwards, when added, then no greatest common denominator. It's line 9. So then what we'd run through here, I guess we can just run through, and then 11 is function GCD takes two params. Let's say parameters. And if param 2 equals 0, return param 1. Else, call GCD again with param 2 and the result of 1 modulo 2, or no, param 1 modulo 2. That's why you're using A and B. I could go back and change that to A and B if we wanted to. Yeah, let's see.
Okay, so line 9 is just for the one where it's like the leak code example. And then line 11 is all of the other stuff, the other two examples.
Yeah, so yeah, I don't need Maram like that. Okay, that's fine. The result of A minus B. So on our first step, right? Let's say A equals, well, it's going to equal. And so the thing is, they're going by the length here, right? So they're ignoring the values and they're just going by the length. And so that's how they're going to find the greatest common denominator. So A equals 10, right? And let's say B equals 2. What's going to happen is it's going to say that is 2 equal to 0? The answer is no. And so then it's going to say, okay, give me 2 and 10 modulo 2, which is going to equal 5. And then it's going to run again. It's going to say, is 5 equal to 0? It's going to say no. And it will say, that's going to be B now. It's going to say 5. Then what would that be? 5 modulo or 10 modulo 5? Yes, it would be 10 modulo 5. Because the result of 10 modulo 2, so B is going to, this parameter and this parameter are getting entered, and this is going to keep increasing. It's going to increase until, as long as it's an even number and they have a common divisor, then it's going to say, is 5 equal to then 5 modulo 2? That equals 2. So then is, no, that would make it 2 again, wouldn't it? There you go. Hmm. Hmm. Oh, but it'll be different on that second one, won't it? If it'll say is 5 equal to 0, 5, 10 modulo 5 is okay, 2. I'm gonna keep following it, even though I think I'm wrong. 0, no. It will say, okay, 2. Oh, but A is, that's it. This is where it's wrong. B is A now. And then it's going to say 5 modulo 5, which is 1. 5 modulo 5 is 1, right? No, then it will say 1, 10 modulo 1. Or modulo 1. Yeah, okay. Then it will say is 10 equal to 0? It will say no. And then that will say 10 modulo 10, which has no remainder. And that's B now. So is 0 equal to 0? Let's say you get to 0. I think. Oh, well, wait. Yeah, 1. 10 modulo 1 is 0. That's 0. That's the 0. So 10 modulo 1 equals 0 is return A. It's going to return whatever A is. Let's walk through this. Let's do this instead. Here. I want to keep walking through. I feel like I understand it. I feel like I understand how it's breaking down, but I'm not explaining it well out loud.
So question,
Yeah.
line 11 doesn't run until line 13 calls it, correct?
Line 11 does not run until line 13 calls it. That's correct.
Okay.
And it calls it within itself. Let's just use, sorry?
Oh, I'm talking out loud, which isn't helpful right now.
Oh, no, it is. It is. I almost want to just collapse this here. Let's say, let's do this. A equals ABC, ABC, and B equals ABC. All right. And we'll just call this, and we'll say, which really means that this is equal to 6 because it's going by the length. So A is equal to 6, B is equal to 3. That's what it's doing. And it's returning the substring. That's the thing, is like, that's how it's taking the substring, which is essentially just the string.
One. Like
Of
it's just
string
going
1.
through string 1, right? So that's like
Right.
just
Let's
the
put this again.
ABC.
Yeah, we'll just do this. We'll stick with the ABC. There we go. So if we could do a T chart here, but Isn't really a t-chart. But to start with, we have ABC, ABC, which is 3, string 1 length. And we know it's going to work is the thing, because it's functional. We checked here, so we know it'll work. And string 2 length is 6th, right? And so it's going to check the modulo of those and return them. The modulo of those will be 2. So that will make B equal to 2 in the next iteration. And it's going to keep calling itself. So it's going to say, and it's going to flip them. It's going to say 2 modulo 6 modulo 2. And the reason it's going to do that is because it's here. And this still equals 6. It's only updating the B. The B is now 2. B is 2, so it's going to be A modulo 2, which will be 3. So then B will be 3, 6 modulo. Stop me if I'm going too far here.
Is 6 modulo 2 not 0?
I think it's 3. Oh, it might be 0. Yeah, 6 modulo 2 might be 0, right? Is that it?
I mean,
Yeah, I
I'm
think you're
not
right. 6
doing it
modulo 2
wrong.
is 0. Yeah.
Okay, I was getting
You're right.
lost again, and I was.
Yeah, 6 modulo 2 is 0.
Yeah, I had to console log it in VS Code because I wasn't sure.
Okay, and substring, I think this command.
So the 0 is like the beginning point for substring because I looked that up and it's
Yes.
just a method, right?
Yeah,
And
okay.
it takes a starting index and an ending index.
Yeah.
So the GCD function is somehow the ending index for string 1
Yes.
substring.
That makes sense. Okay.
But it's very confusing.
Yeah. Well, it'll actually, yeah, it's the ending index. So it'll go from 0 to the point right before whatever GCD returns. That makes sense.
So that's where you're doing that work on line 11. So it checks to see if it is the same number, right? If string 1 and string 2 are like different lengths. So that's where it's doing a lot of work. Okay.
Yeah, well, it's going to take the lengths, and then it's going to say, is B's length equal to 0? If it is, return A. If not, then look at the modulo of their compared lengths, the remainder of their compared lengths, and is the remainder of their compared lengths equal to 0? No. If it's no, then these swap. Then that's the thing, is like,
That's super confusing.
well, it is confusing, but it makes perfect sense. It's just that the values are changing positions to reference. They're changing the references, right?
So once it goes into that ternary operator, it never comes out until it's found its solution, right?
Right. In fact, it's going to keep recursively repeating itself, and then once it finds its zero, it's going to put it back here. And this value is going to contain the endpoint for the substring.
Okay. Okay.
Yeah.
So that's how we get result ultimately. Cool.
Yeah. Right.
Now, that
Yeah.
part on line 11, that second after the ternary operator, that is still confusing.
This?
Yes, that part right there.
Okay. Well,
That is craziness.
if it equals zero, right? If this
If b equals 0, so if string2.length equals 0, then we have our GCD, which is our ending index.
well, the thing is, like, this is the character of B, or it's the value of B, but in the function that we're calling, this is what's going to get returned as B. This is the B parameter, right?
Okay.
This is A and B. That's A and that's B. And every time we recursively call it, we're going to enter in this value is going to get put here, and then it's going to get compared to the value of A, and then we're going to run it again until it equals 0.
So
So
it'll ultimately equal 0?
yes, and we know this because up here we've compared them, and we know that they have a common denominator. And if they have a common denominator, then eventually, if we keep dividing them, we'll reach a 0 point. So it's checking if B is 0. If B is 0, return A. If B is not 0, then put B in A's position, and in B's position is the remainder of their compared lengths. And then it's going to check, and it's going to say, is the remainder of their compared lengths equal 0? Because if it does, this is their common denominator. And if it doesn't, do it again. Keep comparing their lengths until their lengths equal 0. And when their lengths do equal 0, give us back this value, which is represented here. This is the place in the parameter. Even though these are the same ones, this B is equal to this. It's parameter 1, really. Maybe you write it like this. I don't want to break it. Write it like this. We'll say position 1, position 2, position 2 equal to 0, position 1. Nah, it's not like helping. Sorry.
Yeah, no, it's mostly like my brain just has to deal
Yeah.
with the fact that that's how it is. Like, it's not
Right.
wanting to accept it.
It's the fact that parameter 1, or parameter A, the first parameter, is being updated to the value of B. And then the loop is recurring. And then once the loop finishes, if it's not equal to 0, we're going to re-update the first parameter to this result, and then compare that result against the value of this, against the value of the first parameter.
Then, so what would const GCD equal? Would it be like just this a single number then?
It will equal A. when
So
this equals 0, by the time that this equals 0, whatever this parameter is will get stored in GCD.
Okay. So it's ultimately A, but B might take A's place later on down the line if B doesn't
Yeah.
equal 0.
Well, it's ultimately the first parameter.
Okay.
Yeah. And that's why this is the second parameter, and it will be referenced here. The value of this is going to take this, and then this will be a new value. And then if it's still not equal to 0, this new value will be in the first parameter, and the second parameter will be whatever this evaluates to. And if it's still not 0, this will then be the first parameter, and this will reevaluate. And it will keep going until this equals 0. And once this equals 0, we're going to get back whatever it was on the last loop.
Oh, okay. That's a busy
Okay.
line.
It is a busy line. A lot's going on. And then down here, we're taking, we're using the substring function to take whatever that is and find the endpoint of the substring from starting at 0 to here, right? Which is another little thing if you don't know what this does, if you don't know what's going on here. But yeah, that's fine because it's still the right solution and it's very elegant. It's very good. So yeah.
Yeah, it's only 3 lines of code, but man, that middle
Very
line.
good. Man, okay. Well, I'm glad we did that one because I kind of like always had a little fear in my mind of this one. So I'm glad we kind of got through it. How do you guys feel? How do you feel, Franco? How do you feel, Madeline?
Really good explanation. Yeah. I'm glad we took our time with it.
Mm-hmm.
Oh, I've been hyper focused on a front end thing on my other screen.
You want some
Sorry.
help?
Honestly, yeah.
Sure. You want to share? Go ahead.
Really? Okay, sweet. Share screen. Someone else has to stop
Oh,
sharing
I'll stop
screen.
sharing. There we go.
Okay, sweet. So this is the good one. So here's the wireframe, and it's a somewhat nitpicky thing. Oh my God, it worked. The media query worked. Okay. Just kidding. My media query worked. It seemed like it wasn't. And I put in like a margin of 1,000 or something like that because I was just trying to make it obvious. I put it in somewhere else weird in my React application. And I'm doing that thing that front-end developers do where they actually care about the difference of 10 pixels, you know?
Mm-hmm.
And I wonder where I said that there. That's where I said that. But there was actually one other thing too. So does anybody know, and we can take a look, why this right here, the input, is so much bigger than the rest of everything else? Because it's stretching out the whole situation. It's coming all here. It looks, not super legit.
Yeah.
And,
Are you using, so you're writing that CSS on your own? You're not like using Bootstrap or anything?
no, it's pure CSS.
Okay.
And here's the input, and it's pretty basic JavaScript that, as you guys could tell from the fact I zoned out on that JavaScript problem, is not my thing. So of course I find the little form and this stuff online, just giving credit. And here's the input group and the input group. And when I go into here, I'm not saying anywhere that I can tell, I don't think that I told it to be this wide.
Yeah.
Can you tell
Can
anybody?
you inspect that element, inspect the box there?
Yeah.
Can you inspect the other box? The box it's holding it? Okay. It's overflowing.
Yeah, it's overflowing. And I've been trying to sort out, amongst these other little front end things, why it's overflowed. And this is the one that has me the most stumped, which is why I've been leaving it for the last.
Yeah, and it doesn't have any, you're not using any kind of CDN or anything like that reference. Okay. What's it, if you go just outside that box, what's it look like? What's outside that? Okay, so it's going to there. It's running to that edge, right?
Okay, so it's running to the right edge because this must up here have like, you know, a little bit of margin around it. I always mix up padding and margin. I think that's margin.
Mhm.
And then it's automatically running to the right. And is that something that those things automatically do, or did I tell it to do that?
Let's look.
Button, input group, and group label. Margin bottom, width 100%. Interesting. I want to tell it to make the width equal to that. Or
Hmm.
oh,
Yeah, if you make it 100%, you could just add padding, I guess,
is
or
there
margin. You could do padding on the inside of the container.
of the container? If
What's-
I do that, then it will pad this text in and it won't align with the top and it won't be
Mhm.
flush.
What's that guy doing? Font 16, 400.
So for
Could
me,
you just
that
could you put the name and the email field in containers in, like, I mean, they're in a form, right? If they're going to
there
fill 100% of the container, can you just put a container in, put them in a container and then make the or in a div?
in a
It
I
div.
can't hear you, Chris.
You could just do overflow hidden for the name and email. It might
Oh,
chop off that little bit that was hanging over,
That'd be
maybe.
cool.
that sounds concise. Where would I put that though? That's in here?
Yeah, where you changed the width on it a second ago
Mhm.
in the CSS, I think.
Thunder for pure garbage. Look, I know this grudge goes back to mutant.
Yeah, so put it back to 100% and then try the overflow hidden. Oh, shoot.
No, I like that
Sorry.
idea. That sounded novel. I was into that idea. And Brent was suggesting that I put over here these in its own div.
Oh, so that form for your name and email is actually different from the contact stuff?
Yes, because it's like that.
Guys.
Okay.
So they're two separate components. We're in a React application.
So
You
how
probably
do
could.
you, yeah, how do you have the contact form head set up for width? It looked like it was all the same when you were
This here?
inspecting it. No, the contact form part, the head of it. So they give us a call, send us an email.
Oh, that's we haven't looked at that yet. It's over here. And it's in, let's see, I called it entire box. And I just added that in to solve some problem. I don't remember exactly why. And so that's in here. And then over here in the app.js, they're both in half container that I manipulated in the app.css.
Okay.
And over here, half container, you can see all my scrap. But here in the half container, should I say overflow hidden in here?
Maybe.
Oh my God,
Sweet.
you're such a genius. Oh my God, hold on. What's his name?
Success.
Christopher. What a good thing. Okay, thank you so much. That's awesome.
Fantastic. That feels good.
That feels good. That's also really chill of y'all to be down to pivot into
Oh,
the thing.
totally. Oh, by the
Wow.
way, this whole thing was being recorded, so just just hope you don't mind. I forgot to turn off the recording, which I will be
Oh.
doing now. So
That's great. That's cool.
okay, cool.
Someone
Thanks,
learned
everyone.
that.